Hi everyone, so in this video we are going to see how to find the second largest element in a binary search tree. So this question is asked in multiple fan interviews like Facebook, Amazon and Google. So before trying to see how we arrive at the solution, we will see what is binary search tree. So binary search tree is nothing but it's a tree actually. It has a root node and it has a property like whenever the element is greater than the root node, it will be represented in right, and whenever the element is lesser than the root node, it will be represented in left. So here 8 is greater than 7 and hence it is represented in right. Similarly, 4 is lesser than 7 and it is represented in left. So similarly, this property continues for all the nodes I would say. So this is basically a high-level overview on binary search tree. Let's see how to find the second largest element in the binary search tree. So here the second largest element I will say is 7 because the first largest element is 8 and the second largest element is 7. So how to find this? So we can apply this in order traversal. So what is in order traversal? In order traversal is we have to traverse from left, then root, then right. So 3 is left and 4 is root and 5 is right. So the in-order traversal for the mentioned diagram is it will be 3, 4, 5, 7, and 8. So this is in-order traversal. But here, if you need to find the second largest element, then you have to go from 3, then 4, then 5, then 7, which is a time-consuming and it's not an efficient process. So to make it more efficient, we can apply a reverse in-order traversal. So a reverse in-order traversal is nothing but we have to traverse from right, then we have to traverse to root, then we have to traverse to left. So in the above case, the reverse in-order traversal will be 8, 7, 5, 4, 3. So here we can break whenever we have found the second largest element. So 8 is the first, 7 is the second, and we will break, and we don't need to traverse the remaining 5, 4, 3. So that's how this process being efficient. Let's see how to solve this using Java code. I have a main function here. Let's create uh, main function and let's try to create a node actually. I will create a class called node and it will have a data and it will have a left and right node. So I try to create a constructor now and let's try to populate the data and let's try to give the default values for left and right, which is null. Fine. Let's try to create a binary search tree which we already have in the diagram. So node of root is equal to new node of 7. 7 is the root node. Let's see, 7 has root of left as 4. So root dot left is equal to new node 4. Then root of right is equal to new node of 8. So right we have 8. Then root of left is 3. Root of left is equal to new node of 3. Then root of left of right is equal to 5. Root of left of right is equal to 5. Fine. Now let's try to create a function called mm, find second largest node and it will accept uh, node actually. So let's try to create an integer array called count. So we create an integer array because we are going to use recursive calls and primitive int won't support the value level changes whenever we do recursive calls. That's why we need this integer array, or else we can use atomic integer. But currently in our case we are using integer array. Let's define that count as 0. So the count is basically used to find the second largest element. Whenever we hit the count of 2, we will just break it. Then again, we will try to create a new integer array called result, which will try to store the result. Uh, then let's try to create one more function. Let's define all that method is static itself. Public static void. So it's reverse in order traversal, then it will be node of then we will accept integer of count, then integer of result. So here we have to see if the root is if the node is null, then we don't need to do anything. We just return it. Or else we have to check if count the count equal to 2 or greater than 2, then we will just return. So because after the second largest element, we don't need to traverse for the other elements. So here we do a recursive call now, reverse in order traversal. I will go with node of right. Then we'll recursively try to call till we have traversed to the second largest element. We will give count on result. So let's increment the count. So let's see if count is equal to 2, then we will store that in result. So result is equal to node dot data. Then we will return it. So this is how, like, whenever we try to see the second largest element, we will just try to store that data in the result, and we'll just return it. So here we don't need to return also, because after this it will just break. Uh, then we will try to call that from this find second largest element function, where we will give node, we will give count, we will give result, and finally we will return result of 0. So let's try to print that result in the main function. Find second largest element root. Let's try to print. So it should print 7. 7 is the second largest element. So it gives 7. So we have got the correct output now. So this is how we have to find the second largest element. So that's it, guys. Thank you.